Example 9. Okay, for example 9, this is just a generic. I do need to point out a couple things. I did change from when I printed your notes, possibly. So if it's prior to 2021, your notes should be fixed. If it's 2021 or earlier, you'll need to make sure that you change the C column to match these numbers, please. Take a moment to pause the video and change those numbers. Welcome back. Okay, so we have 3 reactants, so we're going to have to use this equation 3 times with respect to C, D, and E. So remember, the first thing we need to do is, in order to figure out which numbers, experiment sets, because we have 5, notice that the reaction goes this way now, top to bottom instead of left to right. So we have 5 reactions, so we're going to have to figure out which reaction sets we're going to do. So what is our numbers going to be here? And when we do that, we look at C. For C, we look at when D and E are both constant. So we use C, look D and E when constant. For D, we're going to see when is C and E constant, and for E, when is C and D constant. So first thing I suggest that you do is underneath each of the columns, you write when you see constants. So first I see 1 and 4, experiment 1 and 4. 1 and 4 for C are the same. I also see that 2, 3, and 5 are the same. 2, 3, and 5 are the same. Continuing on with D, I see that within D, we have only 1, 4, and 5. And then for E, we have 2 and 3. So 2 and 3 are constant. And also E is constant with respect to 1 and 5. Remember, we only do this for the concentration. So now we're going to focus on C, but we're not going to look at C. So imagine you're not looking at C. You kind of ignore this C column, and you're going to look at D and E. So I look here and I see 1, 4, 5. So I can either 1, 4, and 5. So 2, 3, and 1, 5. So the only thing that's constant for D and E is 1 and 5 and 1 and 5. So we're going to pick and we're going to look at 1 and 5 for C. So we're going to set up our formula that says rate 5 over rate 1 equals concentration 5 over concentration 1 raised to an m power. I found these values here from my data table. I put in rate 5 here over rate 1, and then concentration has to be of C, so I put in concentration of C, because this is solving for C, for 5 is 0.2, and concentration for 1 for C is 0.4. I divided those two and got those values. Took the natural log of both sides. Got the same number. I got m equal to 1. Okay, so that is for C. Now, let's look at D. For D, we are going to not look at D, but look instead with respect to C and E when they're constant. I see 1 and 4, 2, 3, 5, 2, 3, 1, and 5. So 2 and 3 is when C and E are constant. So we're going to pick for D, experiments 2 and 3. So we're going to do rate 3 over rate 2, concentration 3 over concentration 2, raised to the n value. I could use m all 3 times. It's just a generic exponent that you're given. So I'm going to plug in 4.55 times 10 to the negative fifth. That's the rate for experiment 3, and the rate for experiment 2 happens to be the same. Then we have 0.2 over 0.5. This would be the concentration of D. Why D? Because I'm solving for D. So the concentration of experiment 3 over the concentration of experiment 5 for D. Why D? Because we're solving for D. Do the division here, and I get 1 equal to 0.4. ln both sides. Of course, the ln of 1 is 0, so we end up seeing that D is a 0 order with respect to D. It's 0 order with respect to D. Okay, so then we're going to look at E, and we're going to not, for E though, I mean when we look at E, I should say, we are not going to look at E, we're going to look at when is C and D constant, and I see 1 and 4 is the case. So we have 1 and 4, so we're going to do rate 4 over rate 1, concentration 4 over concentration 1 to the P. Again, the exponent is just generic. Remember, everything here now has to be about E because we're dealing with E. So rate for 4 is 1.28 to the negative third. Rate for 1 is 7.14 to the negative fourth. Concentration of E, why E? Because we're solving for E. Concentration of E is 0.7, concentration for experiment 4 for E is 0.750, and concentration for experiment 1 for E is 0.560. do the division there, divided that, I got that, I divided those, I get this. So I have the ln of that equals the ln of that. Remember, when I ln both sides, the p drops down, I divide by p, and I get second order. So one thing I did not do, and it was poor modeling on my part, and please so don't follow my lead, you should have written the expression, this piece in red here should have been written on the very first thing before you even tried to do the problem. So be in a good habit of writing this out first. Rate equals k, c to some power, d to some power, e to a power. We are not told the orders. We're not told the m, n, or p. We have data, so we have to use all of this algebraic formula to calculate that. So I apologize for that, but please be in a good habit of writing this down first. I apologize that I didn't model that well. I do expect to see this always. So rate equals k. So now we can actually come in here and we can say now, we can actually write the proper expression based on the data we've collected and the calculations we have made. Rate equals k. We know that c was to the first order, so c would be the present. We can put a 1 there, but that's kind of silly. D was 0. Anything 0 order is 1, so D is not impacted. And then we have e to the second order, so then instead of having p here, we'll make this a 2. And then this would be your final answer. Rate equals k, c to the first order, d to the 0, so it's not present, and e to the second order.